Open your book to page 92. This lesson is on basic definitions of algebraic expression. So first, if you look at the terms, so first one is a variable. So variable, again, think about the word variable, right? Means you're able to vary the value. So that means it's like the variables are like letters. So you use the letters to represent variable because like an x or the y, right? So the value of the x and the y can change, so it can vary, so it's variable, right? Common sense, right? Now the constant. So the next term is constant. Constant is like a number that does not change, like 1 or 5, right? 1 is always 1. It will never become like 10, right? So this is a constant. Constant means does not change. So the value of this symbol does not change, okay? And variable, it varies because x sometimes can equal to 5, sometimes can equal to 10, right? So that's why it's called variable. Now, let's go to the next term. So on page 93, the next term is algebraic expression. Okay, now expression means does not have an equal sign versus equation. So when you see the equal sign anywhere, then it's an equation. When you don't see an equal sign, it's an expression. Okay. And you can look at example 4. There's a whole bunch of examples of that. So if you look at example 4, all those are example expressions because you don't see any equal sign. Okay. The next thing you need to learn is the like term. So let's go to page 93. Okay, on the bottom. Next one is the term and the factor. Term and factor. Term is whenever you see the addition or subtraction, then there would be, those are terms. Factor is when you have multiplication or division. So for example, if you look at example 5, example 5a, you have 2s plus 5t. So this one has two terms. So this is one term, and this is another term. So these are two terms. Now notice this term, the first term has two factors, right? You got 2 times s, right? So this term, so this is your first term, and this is your second term. And this is your factor. So these are all the factors. So the first term has 2 factors. The second term has 2 factors. So again, because of multiplications, these are multiplications. So when you have multiplication, okay, that means it's factor. If it's when you see addition, that is the term. Okay, now let's look at more examples. So let's go to page 94. And let's look at example 5e. So you got 2 minus x over xy plus 5 times 2x squared minus y. Okay, so over here, again, you have so this is count as a grouping symbol. This is a grouping symbol. So the addition subtraction in the grouping symbol kind of got negated, so it doesn't count. So this is your first term, because here's your plus, right? So that's your first term, and this is your second term. Again, notice that addition subtraction, but this one does not count because it's inside the grouping symbol. Notice there's subtraction here, but this is in the grouping symbol because this is a grouping symbol, right? So when you have grouping symbol, the addition and subtraction does not count. So in this case, you got 2 terms. Okay? So again, this whole thing is 1 term. Okay, this whole thing is 1 term. So you got to be able to differentiate the terms. Okay, now let's go to page 94 and let's look at the next term. So there's a lot of definitions. Okay, numerical coefficient. Okay, so numerical coefficient is the number before the variable. So for example, if you have like a 2xy, so numerical coefficient is this one over here. Again, it's number before the variable. That's what the numerical coefficient means. Okay, now let's go to page 95. Like terms. Okay, like terms means they have the same variable. So if you look at example 7, look at A. These are example of like terms. You got 3x, 4x, 1/2 x, 0.7x. All these are like terms. And then if you look at C, you got 5x squared y, 2xyx, yx squared, 2/3 x squared y. So again, all these are example of the like terms because all of them have the x squared y. Now this one, if you simplify this, you get x squared y. Right? This one, the x squared y, x squared y. So like terms means they have the same exact variable part. Okay. Now these are unlike terms. Unlike terms when the variables are different. For example, if you have like a x squared y versus xy squared, again they're unlike, so they're unlike terms. Okay? Or you can have the x, y, again these are unlike terms because they are different. Okay? Now 2x and x squared are unlike terms. These are different things. So again, like terms means the variables are exactly the same. Okay? So make sure you know that. Okay, so let's go over some, let's look at some homework examples. Let's go to page 97. And I'm going to use set 2 as an example. So number 1, it says A, you want to list A, the different constant, and B, the different variable. So 4x minus 7y plus 4. So A, you want to list the constant, so it be 4 and -7, right? So again, you want to list all the numbers. Now they are duplicate already, so all you have to do is write it down one time. So B, you want to list the variables. So you got x and a y. Okay, so again, list the constant, list the variables. Now when you go to number 5, you want to say x is either a factor or a term in the expression. So A, you have x, y. So x in this case is a factor. Okay, you go to B, you got x plus y. So in this case, this is a term. Okay, so this is a factor, this is a term. Okay, these are not true, false. Okay, so this is not true, this is not false. Okay, this is a term, this is a factor. Again, factor is when you have multiplication, terms is when you have addition or subtraction. Right? Okay, then you go to C, you got x plus 4y. Again, it's addition, so it's a term. Okay, you go to D, you got x times y minus 3. Okay, so this is a multiplication, so it's a factor. So you got to be able to tell if it's factor or term. Okay, let's go to number 9. And 9 is kind of easy. Let's go and do number 12. Okay, number 12, you got 3 minus 4x plus 2z. So A, determine the number of terms. So this case are 2 terms. Okay, so 2 terms, because that's 1, that's 2. B, write a second term if that's 1. Okay, so you want to write down the second term. Now second term, you include the sign. So second term is negative, parentheses 4x plus 2z. So this whole thing over here is second term. So first term is 3, second term is this whole thing. Again, addition or subtractions are the separation of the terms. Okay, so it's very easy to tell. Okay, and let's go to number 19. Write the numerical coefficient of the first term. So you got 18x plus 3y. So here's your first term, and numerical coefficient is the number in front of it, so it's 18. So So that's your numerical coefficient for number 19. Okay, so number 27, they want you to simplify everything and arrange in order if necessary, and you tell if they are all like terms or not. So number 27, they want you to simplify. So first one is 9w squared z, so that one's already fine. The second one, you have to combine the z, so it becomes 11w z squared. And the third one is 4w squared z, so that one does not change. The next one is negative 5w z squared, so that one is fine. So only one you have to combine to simplify is the second one. Okay? So that's the first part. You have to simplify each one as much as possible. Then the second part, you have to tell if it's all like terms or not. Are they all like terms? No, this is different from so these two are like terms, these two are like terms, but all of them are not all the same. So this one answer is no. Okay? They ask you, are all of them like terms? The answer is no. Because there are two different kinds. So you got one kind here, and you got another kind over here. So there are two kinds in here. So answer is no. In order to be yes, you have to be all of them have to be the same kind. Okay? And so that's it. Okay, so let's go and do some practice.